In this episode, we're going to describe how cloud attacks tend to unfold and what kinds of damage they create, using three lenses that stay useful even when the platform details change: identity, data, and service abuse. When you are new to cloud security, it can feel like an endless catalog of unfamiliar services, each with its own terminology, and that can make attacks seem impossible to understand without deep specialization. The reality is that most cloud incidents follow a small number of repeatable storylines, and those storylines are usually about how an attacker gets a trusted identity, how they reach data, or how they turn cloud capabilities into something they can exploit for profit or disruption. We are going to keep our focus on methodology, meaning the steps attackers typically take, and impact, meaning the consequences that matter to the organization. If you can explain the attack story clearly, you can also explain why certain response actions are urgent, even when the environment is complex. Think of this as learning to read cloud incidents like a detective, looking for motives and patterns rather than brand names. Identity is often the front door to the cloud, and identity-led cloud attacks usually begin before the attacker ever touches a cloud console. Attackers commonly obtain access through credential theft, password reuse, or stolen session tokens, and they may acquire those through phishing, malware on an endpoint, or data leaks from other systems. Once they have a valid identity, the first cloud-specific action is often a login to a management portal or an API call using access keys, because that is how cloud resources are controlled. The attacker then performs a quick validation step, which is simply confirming what level of access they have and what services they can see. This is where they explore roles, permissions, group memberships, and whether they can elevate privileges by assuming a more powerful role. Identity and access management, IAM, structures can be confusing, but the attacker's goal is simple: find the most powerful set of permissions available from the foothold they have. The reason identity-led methodology is so common is that it makes the attacker's actions look like legitimate administration, which can blend into normal activity unless you pay attention to context. After initial access, identity-led attackers typically try to strengthen their hold, because a single stolen password is fragile and can be reset. This is the persistence stage, where the attacker attempts to create or modify something that will still work later. They might create new access keys, add new trusted identities, register new applications, or modify policies so that their access is harder to remove. They may also disable or weaken monitoring and logging, because visibility is the defender's advantage. Another common move is to create a secondary path through federation, meaning they connect the cloud identity system to something else they control, or they grant permission for external identities to access internal resources. The defender clue here is that the attacker's actions are often administrative rather than destructive at first, because they are building a stable platform for later operations. In cloud environments, persistence can be more subtle than on traditional endpoints, because creating a new key or role can look like routine setup work. That is why identity-led cloud attacks can become severe before anyone realizes what has happened. The impact of identity-led cloud attacks depends heavily on the permissions of the compromised identity, but the range can be very broad. At a minimum, identity compromise can lead to unauthorized access to resources the identity is allowed to view, which might include sensitive files, internal dashboards, or customer data. With higher privileges, the attacker can change configurations, create new resources, and potentially exfiltrate large amounts of data quickly. A powerful identity can also disable security controls, modify network boundaries, or change access policies to widen exposure. Even when the attacker does not have full administrative control, they can still find ways to escalate by discovering overly permissive roles or misconfigured trust relationships. The most damaging aspect is often the attacker's ability to act as a legitimate administrator, because it can undermine audit confidence and make it hard to distinguish normal operations from malicious ones. In short, identity compromise can transform the cloud from a controlled environment into a tool the attacker can steer. Data-focused cloud attacks can begin with identity compromise, but they can also begin with exposure, meaning data is reachable without proper access controls. In many incidents, a storage location or database is configured with permissions that allow public access or allow broader internal access than intended. Attackers find these exposures through scanning, by following links, or by discovering that a resource responds to unauthenticated requests. The methodology in these cases is often simple. Access the exposed resource, enumerate what is available, and copy what can be copied. If the exposure allows modification, attackers may also upload content or tamper with data, creating an integrity problem rather than just a confidentiality problem. Data attacks are appealing because the payoff is often immediate, whether that payoff is selling data, using it for fraud, or using it to support deeper intrusion. For defenders, the key point is that data attacks can be fast, because copying data can happen quickly once access is available. Once attackers access cloud data, their next step is often to maximize value by prioritizing what is most sensitive or most useful. They may look for personal records, credentials, financial information, intellectual property, or internal operational details like architecture notes and keys stored in configuration files. Even when the data itself is not directly monetizable, it can be used to make the attacker's next steps easier, such as identifying administrators, learning internal naming conventions, or finding links to other systems. Attackers also sometimes target backups and logs because those can reveal secrets or provide a roadmap of the environment. A subtle impact of data exposure is trust erosion, because even if systems keep running, stakeholders lose confidence in the organization's ability to safeguard information. Another impact is regulatory and contractual risk, because exposed data can trigger reporting obligations and legal consequences. So even when the incident feels like just a leak, the downstream effects can be large and long-lasting. Service abuse is the third lens, and it is often about using cloud resources as a platform for the attacker's own goals rather than directly stealing a specific dataset. A classic example is unauthorized compute usage, where attackers spin up resources to run workloads that benefit them, such as large-scale computation, mining, or hosting. Another example is using cloud messaging or email sending capabilities to distribute spam or phishing at scale, because cloud infrastructure can provide reach and reliability. Attackers may also use cloud storage and content distribution to host malicious files or to stage data stolen from elsewhere. Service abuse often becomes visible through cost anomalies, resource spikes, or unusual usage patterns that do not match business activity. The attacker's methodology typically involves gaining enough permissions to create or control resources, then automating the provisioning and use of those resources. In some cases, the attacker tries to hide their usage by spreading it across regions or accounts, or by keeping resource names and tags similar to normal ones. The impact here can be financial, operational, and reputational all at once. A key part of understanding service abuse is recognizing that attackers treat the cloud like a vending machine for capabilities, and identity is often the coin they use. If they compromise a credential that can create resources, they can rapidly scale their abuse. If they compromise a system that holds access keys for automation, they might gain permissions that are broader than any single human user's. Misconfiguration can also enable abuse if guardrails are missing, such as when resource creation is not restricted or when billing alerts are not monitored. The financial impact can be immediate because cloud consumption can ramp quickly, and the organization may receive a surprising bill even if the incident is caught within days. Operational impact can happen if the attacker's resource usage hits quotas or limits that legitimate services rely on, causing business workloads to fail. Reputational impact can occur if the abused resources are used to attack others, leading to blacklisting or loss of trust. This is why service abuse is not a minor nuisance. It is a serious incident category with multiple consequences. These three lenses are not separate worlds, and most serious cloud incidents involve movement between them. An attacker might begin with identity compromise, use that access to find and exfiltrate data, and then use the environment to run abusive workloads or to stage further attacks. Alternatively, an attacker might start by discovering exposed data, use that data to find credentials or keys, and then pivot into identity compromise that unlocks deeper control. This interconnection is why cloud attack methodology often feels like a chain rather than a single event. The important beginner skill is to notice the transitions, because transitions indicate escalation. When the story moves from a single suspicious login to the creation of new keys or roles, the attacker is trying to persist. When the story moves from access to mass downloads, The attacker is monetizing data. When the story moves from access to resource provisioning, the attacker is turning the cloud into a tool. Each transition changes what you should prioritize in response. Another helpful differentiation is the difference between control plane actions and data plane actions, even though you do not need deep platform knowledge to use the idea. The control plane is where you manage the environment, such as creating services, assigning permissions, and changing policies. The data plane is where actual workloads and data move, such as reading files, writing to databases, and serving application traffic. Identity-led attacks often start in the control plane, because that is where the attacker learns what they can do and sets up persistence. Data attacks often show up in the data plane through reads, exports, or unusual access patterns. Service abuse often starts in the control plane by provisioning resources, then shifts to the data plane where those resources generate traffic and consumption. If you keep that distinction in mind, you can better interpret evidence and impact even when you cannot name the exact service. It also helps explain why some incidents look like administrative changes while others look like unusual data movement. Cloud incidents also tend to have a particular risk multiplier: centralized identity and automation. Centralized identity means one login can grant access to many services, so identity compromise can rapidly become environment compromise. Automation means access keys and service identities may have broad permissions to keep systems running smoothly, and those permissions can be exploited if the keys are stolen. A beginner might assume that machines are safer than people because machines do not click phishing links, but machines can be riskier because their credentials are often long-lived and powerful. Attackers know this, which is why they look for secrets stored in configuration systems, deployment pipelines, and application settings. The impact of stealing a powerful automation credential can be more severe than stealing a single user password, because it can allow actions across many services without interactive checks. This is why cloud incidents often feel like they expand quickly. The environment is designed for speed and integration, and attackers use that design to accelerate their own actions. To describe impact clearly, it helps to talk in terms of what was exposed, what was changed, and what was consumed. Exposed refers to confidentiality, such as data accessed, data copied, or secrets revealed. Changed refers to integrity, such as permissions modified, policies altered, configurations adjusted, or resources created and deleted. Consumed refers to availability and cost, such as resources used for attacker workloads, service quotas exhausted, or bills inflated through unauthorized usage. Identity-led attacks often create all three impacts because control plane access can lead to exposure, change, and consumption. Data-led attacks emphasize exposure first, but can also include change if the attacker can modify stored content or inject malicious files. Service abuse emphasizes consumption, but can also include change, like creating persistent resources, and exposure, like using the cloud to store stolen data. When you can describe impact in these terms, you communicate clearly without needing to recite platform-specific jargon, which is especially useful for beginner-level understanding. As we close, remember that cloud attack methodology is usually a story of how an attacker gains trust, then uses that trust to reach what they want. Identity attacks are about becoming a trusted actor in the environment, often followed by persistence moves like new keys and role changes. Data attacks are about reaching sensitive information, either through exposed resources or through authorized access that is misused for mass collection. Service abuse is about turning cloud capabilities into a resource for the attacker, creating financial, operational, and reputational harm through unauthorized usage. These categories overlap, and the most useful skill is noticing which lens explains the incident right now and where the attacker is likely to go next. When you can describe both the methodology and the impact through identity, data, and service abuse, you create a stable framework that works across different cloud platforms and different incident stories. That framework is what lets you stay calm, communicate clearly, and make good decisions even when the details are messy.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.